Hi, everybody. This is Aaron Schwartz, and we've gotten a couple of requests for a video that highlights how students who are conceptually proficient would be attempting assessment items and the strategies that they would employ. So, in this video, we're going to look at some very typical assessment items that you'll see on the formatives, and they're very typical of what you would normally see on not just the formatives, but on assessments like PARCC to assess students' understanding of quadratics. As we go through the video, we're going to be contrasting the approaches of a conceptually proficient student with those of a student who is very fluent at just procedure and doesn't really have a deep understanding of the content, even though they've memorized a lot of procedures. As we go through it, we're also going to highlight the times that it may take for students who are conceptually proficient to complete the problems versus those students who are just plugging away at procedures. So let's go ahead and start with Unit 4, Topic 1, and we'll look at a couple of items from the formatives in that unit. One of the typical items that we'll examine is being able to use a quadratic function to describe various stages of a diagram, usually something that has to do with area, like the mosaic diagram that we have here. So normally we ask students to write an expression that models the quadratic. A conceptually proficient student has gone through the first couple of SLTs in this topic and really started to think about quadratics as area, as length versus width, particularly in the case of rectangles. So a conceptually proficient student is going to look across these different sizes, and they're going to start thinking about rows and columns. In size 1, I have 2 columns. In size 2, I have 3 columns. In size 3, I have 4 columns. So my number of columns is always one more than whatever stage or size I'm on. They're next going to think about the rows. In stage 1, I have 4 rows. In stage 2, I have 5 rows. In stage 3, I have 6 rows. So I've got 3 more rows than I have whatever stage I'm on. And as a result, the area for this is going to be modeled by the quantity x plus 1 times the quantity x plus 3. A conceptually proficient student is going to pick this up because of the rows and columns, and they're going to be done this part in about 30 seconds. Now, if we were to ask them to give 2 forms of the quadratic, say this factored form and a standard form, a conceptually proficient student is now going to switch how they view the diagram, and they're no longer going to be viewing rows and columns, but they're going to be looking for numbers of perfect squares, linear rows, and extra constant pieces. And they may view it like this. And this models very well what you would see in, say, algebra tiles. Let's start with stage 5, which is actually the reverse of where we would normally start. We can see that in stage 5, we have one blue block that is 5 by 5. It is a perfect square. So we have one perfect square of 5. We can also see that we have 4 rows, actually 3 rows and 1 column, but we're going to say it's 4 rows. So 4 linear pieces that are 5 in length. And you'll see that across the top and across the side. So if I highlight that, we're talking about those rows right there and the column on the side. And they're also going to see that they have 3 constant pieces. And as they look backwards through the diagram, that pattern holds out. So a conceptually proficient student will describe this as a perfect square of x, 4 linear pieces of x, and 3 constant pieces. Now, a conceptually proficient student has actually developed both of these expressions without any algebraic procedure. So if they were to do only one of those expressions, we might expect them to take about 30 seconds to do this problem. If they're doing both of those expressions, maybe a minute and a half at most. Now let's contrast that to the student who knows a lot of procedures, but doesn't have those connections. So they may start by building a table, something like this. where they have the stage, the columns, the rows, and the total. And they're going to go ahead and they're going to start writing out their table and filling it in. And if they're really proficient with that table, they may notice that they can describe the columns as x plus 1 and x plus 3, and that's their total. And so writing out that table isn't wrong, but it's going to take some time. And so now that student is taking a minimum of 2 minutes. Now, if they want to do the standard form for this, they're either going to have to do the algebraic manipulation and multiply it out. And that's going to not only introduce extra time, but extra places where they may make an error. And so this student who has a lot of procedures memorized is now looking at not just 2 minutes, but maybe 3, 4, even 5 with the algebraic manipulation and double checking work. That same student could also get that standard form by plugging into the calculator and doing a quadratic regression. However, they're going to have to know to do the stage versus the total. And plugging that in is going to take about as much time as the algebraic manipulation. And again, you're introducing more places where the student could get it wrong. Maybe they mistype something or they press the wrong button. And as a result, that student knows a lot of procedures, but they're taking about 3, 4, maybe even 5 minutes to do this whole item, whereas the conceptually proficient student got it done in 1.5 minutes or less. Let's take a look at another item. So this is from the last few lessons that are in Unit 4, Topic 1, and it's a typical problem that you might see both on PARCC and on our formatives, where you're actually asked to classify the functions. You're not asked to give the equation for each. So a conceptually proficient student has gone through this exercise where they have noticed some things about the first difference when they examine tables. So the first thing that conceptually proficient student is going to do is look for their first differences, because they know that's going to tell them the function type immediately. Starting from the left, 0, 6, 14, 24, 36. If I just do my first differences, I see that the first differences have a linear pattern, which means that the function was quadratic. Now, a student may go ahead and plug all these values into the calculator and try to do a regression. Again, that's going to take time. So something that was 30 seconds is now going to turn into 2 minutes. Let's take a look at Table 2. 0, 8, 16, 24, 32, 40. Well, this is actually work that we've done since Unit 2. We're going plus 8, plus 8, plus 8. Because the pattern is constant, the function is linear. Now let's look at this last table. 0, 2, 6, 14, 30, 62. These are not numbers with which I'm really comfortable working, but if I do my first difference, something is revealed immediately. 2, 4, 8, 16. I could even go to the next number, which is 32. I have this multiplicative pattern. This is exponential. So a student who has that deep conceptual understanding and that deep meaning behind the first differences, they're going to do all 3 of these in about a minute, maybe 1.5 minutes at most. Whereas the student who has to do regressions on their calculator to figure out what these are, we're talking about 6 minutes for all 3 of these. It's really going to be a long time for them to do this item. So while both students may get it right, we're starting to see that the conceptually proficient student is going to be able to do these kinds of assessments in 20 minutes or less, whereas the student who really just knows a lot of procedures and calculates everything, they're going to run out of time. Let's take a look at some more items. This time, we're going to look at Unit 4, Topic 2, the structure of quadratic expressions. This is actually one of the most important areas of study all year long, because this is one of the areas that has far-reaching impacts, not just within later parts of Algebra 1, but in Algebra 2, pre-calculus, and even calculus. What this allows us to do is understand the vertex form of a quadratic as a transformation and as the generalization of transformations for any type of function. So let's start looking at some typical items. On one of the formatives, there's a sequence of questions, numbers 5, 6, and 7, that really assess conceptual understanding of transformations and the meaning of the values in the equation in the context of transformations. Now, students are going to notice that there are no numbers in this item except for the zeros. And that's really important because what we're really trying to gauge is, do they understand what these transformational scalars and constants do? So for the first one, number 5, we're given a function in vertex form, and we're asked if the vertex of the parabola is a maximum and located on the x-axis, what are the relative values of a and k to 0? Now, a student who's conceptually proficient is going to immediately think about the fact that a maximum means that we're opening down or that a is negative, which means that a is going to be less than 0. Then they're going to think about the k, and they're going to think about the fact that the vertex is located on the x-axis. And what does that mean in terms of translations? Was it translated up or translated down? Well, if k was positive, they're going to rationalize that it was translated up, and if k was negative, it's been translated down. Since the vertex is on the axis itself, there was no translation. So k is exactly 0. Now, a student who's conceptually proficient is just kind of going to rationalize these. They may sketch something at most, so that we're really talking about 45 seconds to a minute for this item. Whereas a student who knows a lot of procedures may start to do something like substituting values for a and values for k into a calculator, seeing what happens, and trying to make those conclusions during the assessment. There's a good chance that they'll get there, but it's going to take several minutes. Again, one student's going to do this in about 45 seconds to a minute, whereas another student is going to take 5 minutes. So when you're going through the lessons on more than meets the y and shifty y's, and those are the first 2 SLTs, it's really important that students don't just memorize a bunch of rules, that they really understand what it is that these values do in a much larger and much more abstract sense. When we look at the next item, number 6, we're now given the same scenario except a minimum and 2 real x-intercepts. So again, we're talking about the vertical translation and the scalar that's used to either reflect the parabola up or down. Again, the conceptual student is going to look at this and go, okay, it's a minimum, that means it's really opening up, so a is positive, so a is greater than 0. Now they're going to think about that k value, and they're going to start thinking about, okay, how do I get 2 x-intercepts? Well, if I move it up, I don't have any, and if I move it down, I'll get 2 x-intercepts. So k is negative, which means k is less than 0. Again, a conceptually proficient student is going to do this in about 45 seconds to a minute, maybe with a sketch, whereas a student who really doesn't understand the content at that depth and is trying procedure to figure it out, they're going to take a couple of minutes for this item. Let's look at number 7. This is the only one that assesses the horizontal translation. Now, if we have the axis of symmetry on the y-axis, we have to make a conclusion about the value of h. So let's think about that. Okay, h is the left-right transformation. A conceptually proficient student is going to realize that when h is negative in the context of x minus a minus h, that means that we've translated to the left. When x is positive, that means, when h is positive, that means we've translated to the right. But when h is 0, there's no translation or transformation, and so the y-axis is the axis of symmetry. So for this to be true, h has to equal 0 exactly. Again, a student who is not conceptually proficient may take a couple of minutes on this one. Now, this they may only take about 3 minutes because there's only one value that they have to manipulate. But the conceptually proficient student is going to be fine and get through this item 30 to 45 seconds at most. Now, another part of the transformations is writing the equation given the graph, and that's what we're asked to do here. We're asked to give specifically the vertex form. And the reason to give the vertex form of this is to really see whether or not students understand what the vertex form represents when given a graph. A conceptually proficient student is going to right away label the vertex. It's not that big a shock, but it is an important place to start. The next thing that they're going to do is they're going to think about some of the material from Unit 4, Topic 1, specifically the patterns of change and how the A value is related to the lead coefficient. So they're going to start writing out their second differences. They'll start with their first differences, -1, -3, -5. They'll write out their second differences, and they'll realize to take half of that. A is going to be equal to half of -2, or just -1. The next thing they'll do is just plug the numbers into the equation. F of x equals -1 times the square of the quantity x minus 6, increased by 9. That's all they'll do. One of the difficulties that you'll see with procedurally proficient students who don't really understand the content is they're going to approach this item in several different ways. Students who've memorized a lot of procedures may give you the factored form. And this isn't as shocking as it may appear. It means that they've memorized a lot of things, but they don't really understand what each of them does and when to use them. The other thing that they may do is they may actually do something where they do a quadratic regression on their calculator by putting in the ordered pairs that they see on the graph. Now, the problem with this is that the quadratic regression generally gives you the standard form. So a procedurally proficient student is now sitting there with the standard form, and they now have to complete the square to get the vertex form. That's a lot of work. They're going to approach this item, and it's going to take several minutes if that is their go-to procedure. So again, the student who's really conceptually on it is going to realize how simple this item is, and that the A value is the only part that requires work. So probably 45 seconds to a minute. Whereas the student who really doesn't understand the content is going to try lots of algebraic manipulation or lots of things on their calculator that just are not going to get them the answer quickly. I mean, it's going to take them several minutes, probably about 4 to 5. Let's look at some more items. Number 2 and number 3 on this particular formative assessment really measure whether or not students understand what it means to have a perfect square trinomial and some of the relationships. So for example, in number 2, we're looking for the value of the constant that makes the trinomial a perfect square. Now, if students did the building the perfect square lessons and those algebra tile lessons that are right after the transformations, they're going to be okay. What we really want to see, though, is that they have used those algebra tiles in a particular way. They have used their algebra tiles to get to a procedure, and they really understand what's happening. In the course of their experience, they should have noticed that when you have a perfect square, your linear term is double the constant that's inside your parentheses. So they are going to realize you just take half of 14, that's 7. 7 squared is 49. They're done. That's all they're going to do on this item. It's going to take 30 seconds. Now, a student who went through a lot of work with the algebra tiles, but used those algebra tiles as a replacement for the procedure, instead of discovering what the procedure would be, is going to draw out those algebra tiles. And the moment they have to draw out and count 49 tiles, it's a 4-minute item. They're just going to take forever to draw this out. And so they really don't understand the procedure in the context of a representation of those tiles. Now, number 3 is the reverse of number 2, because in number 3, you're given the constant and you have to identify the linear term that makes it a perfect square. So again, the conceptually proficient student is going to recognize that they're just doing the reverse. So instead of taking half and then squaring, we'll invert the operations in the order. We'll square root and then we'll double. So we're going to do the square root of 81 is plus or minus 9, and double that is plus or minus 18. And so B is plus or minus 18. Again, conceptually proficient student who engaged with the tiles to understand what the procedure would be, they're going to take 30 seconds. A student who's using the tiles as the procedure itself, they're going to be stuck drawing out 81 tiles, and they're going to be miserable, and it is going to take them 5 minutes or more. Let's take a look at another item. Which is the correct standard form for the quadratic expression, the square of the quantity x plus 1 minus 5? Now, there are several ways to approach this, and I'm going to start with the conceptually proficient student. The conceptually proficient student at this point should recognize that when you have a perfect square and you have that vertical translation, what you're going to do is square the x, double the constant, and that will become your linear term. And then square the constant, and that's going to be your constant at the end. And then you'll have to apply the vertical translation. So let's start with that. The square of x is x squared. That doesn't eliminate any choices. 2 times 1 is 2x. 2 times 1 will be the coefficient 2x, which doesn't eliminate any of the choices. So we now have to square the 1. 1 squared is 1. 1 minus 5 is negative 4. The answer is D. Now, a student who knows a lot of procedures is going to try a couple of things. They may actually do algebraic manipulation on this item. That's probably going to take about 2 minutes, maybe 3 minutes. Another option is going to be to graph all 4 of those and then compare it to the graph of the vertex form that's given in the prompt. What that means is they're spending lots of time graphing that a couple of quick calculations would have taken care of. If they really understood what it meant and what they needed to do to convert the different forms, they're going to take that 30 seconds to 45 seconds on this item. The moment they start graphing, the moment they start algebraic manipulation, we're looking at 3.5 minutes. So we've really slowed down this problem if the only thing we know how to do is a bunch of procedures. One of the major standards is to complete the square for a quadratic to reveal the vertex. So we're going to do that in number 5 on this particular assessment because it is such a major standard in the Common Core. So we're asked to complete the square. Now, one of the things that's very important is that when we're asked to complete the square, we need to demonstrate a process that shows we know how to complete the square. There's a wide variety of ways to do this, but if we do anything other than completing the square, we're not really showing mastery of that concept. Now, a student who's gone through those building the square lessons and worked with the algebra tiles should have gotten to the point where they're going, okay, half of the middle term, when I have a lead coefficient of 1, square that, and then figure out what the difference is between my constant and what the constant should be. So their process for completing the square may look like this. Half of negative 12 is negative 6. Negative 6 squared is 36. 28 minus 36 is negative 8. So f of x is equal to the square of the quantity x minus 6 minus 8. Done. Part A, done in 45 seconds to a minute. One area where students who are procedurally proficient but not conceptually proficient may approach this problem is by drawing out the algebra tiles. That's going to take a long time with 12 linear pieces and 28 unit pieces and trying to figure out what's missing from my perfect square. That's going to take a very long time. Another one is if they try to do things like factoring, or if they try to use the calculator to graph it and determine the vertex, and then they're going back and trying to figure out how to make the work show that they actually knew where the vertex was, even though they didn't. That's going to take enormous amounts of time. We're talking about 8 minutes if you're going back and forth between these different forms. Whereas that student who was really conceptually proficient went, okay, I know what numbers I have, I know what I need to do, done. Now, when they go to reveal the vertex, they're just going to say 6, negative 8. So this is a perfect example of where a student might be able to get this right with enough work if they're procedurally proficient, but it's going to take a very long time. And so if they're running up to you at the bell with the correct answer versus the student who gave it to you 20 minutes ago with the correct answer, that's a really strong indicator of the approach and mindset that the students had in the assessment. We've got another one where we're going to talk about just how the conceptually proficient student is going to do this. We're going to factor this time, and a conceptually proficient student has discovered the patterns that underlie factoring, both with lead coefficients of 1 and lead coefficients not equal to 1. And they're going to look at this item and go, oh, this is an easy factoring because I have a lead coefficient of 1. So I'm just looking for what multiplies to 14 and adds to 5. So they may not even write this out, but they're thinking, what are the factors of negative 14? Which ones have a difference of 5? That's 2 and 7. And so which one do I need to make negative? Well, it's going to be my 7. So x minus 2, x minus 7 times the quantity x plus 2. Done. Conceptually proficient student is doing this on the fly in just a few seconds. The student who really relies on algebraic manipulation is going to set up the chart and is going to write it out, or they're actually going to do factor boxes, or they're going to do factor by grouping in some way. And so they're going to be spending a lot of time on algebraic manipulation that's just not necessary. Now, one thing that a lot of people say is that, well, my students don't know their multiplication tables. And that is a common issue. And as an 8th grade algebra teacher, I encountered that a lot. But during the instruction, I was giving students multiplication charts because it allowed them to quickly and easily look up the factors that would multiply to a certain amount but add to a certain amount. And one of the things that happened as a result is that when we got to the assessment, students were able to do many of those multiplication facts without the chart. They had gotten so much practice during the instruction that they were reminded of the multiplication facts of which they had difficulty, and they just didn't need them when they got to the assessment. Now, this one is one of the first questions on the third formula from this topic, and this is a really good item because it brings together a lot of knowledge. And the way students approach this item is the difference between it really taking about 2 to 3 minutes to do all three of these and taking 10 minutes to do all three of these. So let's approach it from that conceptually proficient student. The conceptually proficient student is going to look at their table and they're going to notice right away they have their y-intercept. Boom, we have our constant for our standard form. No calculations. The next thing they're going to do is go, okay, where are my x-intercepts and where are my vertex? Well, I see an x-intercept here. Let's find the other one. They're going to recognize they don't have it, and they'll continue the table out. The next x-intercept is at 7. I now have most of what I need to do factored form. So let's go ahead and do the a value, because then I can be certain of what I need to write. I'll do my second differences, my first differences, and then my second differences. My second differences are 2, half of that is 1, so this is going to be an easy item. Let's do my factored form. 1, x minus 3, x minus 7, because I know my x-intercepts. Done. And I can now do my standard form really easily. With the lead coefficient of 1, I'm just talking about x squared. And for my linear term, I just have to add my constants and then multiply it by x. -3 plus -7 is -10. Throw in the x. We have -10x. I have my 2 of my 3 forms, and I haven't spent much time on this item. The last thing I need to do is my vertex form, which means I just need to look for the point of inflection or the point of symmetry in my table. Right there. So on the left and right side, the range values are the same. So there we go. I already know my A. I already know my H and my K. We're done. And this item took me about 2 minutes if I'm conceptually proficient. It's really important that teachers recognize that as we're using our formative assessments along the way, it's not just whether students got things right or wrong, it's how they approached it. And one of the best indicators of how they approached an assessment is the time it's taking them to do items. When students are conceptually proficient and strategic about their approach, items take about 1 minute to 2 minutes at most. When students are relying on a lot of memorized procedures and don't really understand the math and the patterns behind those procedures, they're going to start applying procedures to every single problem, and they're not really going to strategically rationalize their way through. And as a result, by plugging away almost by brute force, they're not taking 1 minute and at most 2 minutes per item. They're taking 5 or 6 minutes per item. And the result is that assessments that should be done in 20 minutes or less are taking 45 minutes or more, even if they get all of them right. These strategies are not just good for these assessments, they're good for all assessments. And it's the way that we want students approaching any particular item. What is it that's really being asked here? What do I know about this information that I can use to answer the item? And just kind of reasoning their way through before brute forcing it with procedure. I'm happy to make more of these videos. If there are any particular requests on behalf of teachers, please email me. I'm glad to support teachers as they're looking for better ways to reach their students. Once again, this is Aaron Schwartz, and thank you and have a great day.